To chair the first session, which is on cognition and consciousness across species. I also invite the other speakers of that session to take their chair at this place. So that would be Tetsuro Matsuzawa, Soumya Iyengar, and Binoy. Thank you.
Thank you very much, Sangeeta. Good morning, everyone, and welcome to the first session of this conference, which is on cognition and consciousness across species. Let me just say a few words to set the stage for this session. Empirical and observational studies on the cognitive abilities of non-human species and their underlying mechanisms develop primarily because we assume that their intelligence and, if one may use the term mind, are most like our own. Through our understanding of them, we would therefore one day possibly understand what it is to be essentially human. However, this view that non-human and human species represent a continuum in mental abilities coexists in our minds rather uneasily, I think, with the equally pervasive idea that non-human species differ fundamentally from us because they lack sophisticated language and may thus lack some of the capacities necessary for reasoning and abstract thought. Comparative studies on different taxa along the primate lineage, for example, nevertheless may throw light on the nature and evolution of different human cognitive abilities, including that very elusive phenomenon, consciousness. One particular functional perspective provides a categorization of consciousness into perceptual consciousness, the state or faculty of being mentally conscious or aware of anything, and reflective consciousness, the recognition by the thinking subject of its own actions and mental states. Thus, if an animal was perceptually conscious, it would be able to believe, think, or remember. But if it was reflectively conscious, it would be aware of its beliefs, thoughts, or memories. Current thinking holds that some mammalian species, including higher primates, dolphins, or elephants, may be perceptually conscious, but are unlikely to be reflectively so. But what I want to stress here is that the principal reason for this bias against the belief that these species can reflect on their thoughts and actions is methodological. People can tell us what they are aware of, animals cannot. These perspectives that I'm talking about, of course, depend on several theoretical frameworks to investigate cognition in animals in terms of mentalistic notions. One such framework for perceptual consciousness is that of the intentional stance, which assumes that each individual is an intentional system capable of mental states. Another important functional framework that encompasses attribution, in other words, it tries to understand whether an individual is capable of attributing thoughts, emotions, and desires to another individual, is what has been argued to have a theory of mind. Social animals in particular appear to be knowledgeable about one another's behavior to different extents. But do they know as much about each other's beliefs and intentions? Are they adept at recognizing the similarities and differences between their own and other states of mind? Behavioral decision-making processes need to be analyzed very carefully in these non-verbalizing species in order to ascertain whether higher order intentionality can indeed be invoked as underlying mechanisms governing behavioral acts. More complex manifestations of the ability to attribute mental states and perspectives to others would also seem to require that individuals be reflectively conscious and possess some degree of self-awareness. For individuals to clearly distinguish between their own thoughts and beliefs and those of others, for example, would obviously require some accessibility to their own minds. Current evidence for self-awareness in animals seems to be patchy and inconsistent. Self-recognition refers to the ability of an animal to distinguish oneself from others without implying any awareness in doing so. Self-consciousness, in contrast, is a kind of meta-self-awareness which implies that an individual is aware of its own state of mind and can use this awareness to predict and explain the behavior of both oneself and of others. This distinction becomes important because very few mental processes ever become accessible to consciousness. Hence, it is entirely possible that animals may be able to recognize its own position in a social group distinguish between its own motives and those of others, and even attribute some beliefs to others without having reflective access to their own minds. In other words, they could be blind, they could have blind sight. Higher order intentionality can be effective, however, only in the presence of some degree of truly reflective consciousness. To successfully deceive an audience, for example, an individual must be able to attribute false beliefs to others, and this can be achieved only if an animal is capable of comparing its own knowledge with that of other individuals. Such a task clearly demands at least some level of self-consciousness, including an ability to be introspective. We hope to explore during this meeting, and particularly this session, some of these theoretical and philosophical issues in animal cognitive psychology, ranging from mental representation to distributed cognition, from simple, possibly learned behavioral responses to more complex, self-based decision-making mechanisms, ultimately leading to the current status of our understanding of higher cognitive processes and consciousness in non-human species vis-à-vis ourselves, humans. So let me begin this session by inviting Professor Tetsuro Matsuzawa from the Primate Research Institute of the University of Kyoto in Inuyama in Japan to deliver the first talk. Professor Matsuzawa.
Good morning. It's my great pleasure to be here to talk about my study on chimpanzees. Please focus on the slides. Outline of talk today, I will give you the introduction first that illustrates my research in the field and in the laboratory. And that is followed by 4 major topics: imitation, language, social bond, and imagination. So, introduction. The key question is, what is uniquely human? This is Japanese monkeys. Well, I really prefer the dark room. So could you turn off the light, please? Because for the video presentation, I really need the dark room. Thank you very much. Not many people recognize there are no monkeys and apes in North America and in Europe. No American monkeys, no British monkeys, no French monkeys, no German monkeys. So look at the map. Green area occupied by non-human primates in Central South America, Africa, India, and Southeast Asia, including Japan. This means there are no monkeys and apes in North America and in Europe. So Japan is very rare country that has indigenous native monkey in the summit country or G7 country. So what is uniquely human? The key question, why I'm focusing on chimpanzees. That is the idea of outgroup, paying attention to the outside. That may bring you the insight about in-group. So for humans, what is outgroup? That is chimpanzees, gorillas, and orangutans. Orangutan, gorilla. Orangutan, gorilla. Orangutan, gorilla, orangutan, gorilla. Orangutan lives in Borneo and Sumatra, Malaysia and Indonesia in Asia, gorilla in Africa, chimpanzees in Africa, bonobos, the same genus, different species of chimpanzees in Africa. The relationship between chimpanzees and bonobos is Homo sapiens and Homo neanderthalensis. As you know, Neanderthal man lived in up to 30,000 years ago in Europe. So Homo one genus, two species at that time, but gone, only Homo sapiens. But Pantroglodytes, Pampaniscus, chimpanzees, bonobos, at present. And they are from Africa, and we are from Africa. So take-home message is first, human is a primate. Human is a primate species. So say non-human primates for monkeys and apes. They are non-human primates. We are human primate. Don't say human and primates. Primates include humans, okay? That is very important point. Then chimpanzee is not a monkey. Chimpanzee is a hominid. Chimpanzee is called ape, you may call ape, but not monkeys. And chimpanzee is a family of hominid. Look at the bottom of gorilla. This is gorilla. No tails. Chimpanzees, bonobos, no tails. Orangutan, no tails. We humans, no tails. Right? So we are the same family. We are not monkeys. We are hominid that has no tail and big. So people used to do the study of chimpanzees in the laboratory and also in the wild, and use careful observation in the field. And you do the precise experiments in the laboratory. That's fine. But if you make the 2x2 contingency table, there are two missing windows. You may do the experiments in the field, what I named field experiments. You may do a careful observation in the laboratory, what I named participant observation. I will give you the explanation. So laboratory experiment called I project started in 1978, April 14th. So I chimpanzee, now 39 years old, from 1 year old on, so 38 years, I have been studying these chimpanzees. The first paper published in Nature 30 years ago. So that is done in the Primate Research Institute of Kyoto University. We have a group of 13 chimpanzees of 3 generations in a group. That outdoor compound is connected to the 2 huge cages, green one and silver one. I want to show what's going on at the moment. So from chimpanzee viewpoint, 1, 2, 3, 4 entrance to the cognitive test booth. So 24 hours a day, whenever you want, you may come into the booth to do the test. So this is a brand new facility. So everything is predetermined, controlled by the computer. So the experimenter makes a cognitive test, 1, 4, 2, 7, 9, touching the numerals in an ascending order. And the correct response is rewarded by a tiny, 8mm cube of apple. So this is really the size of Antiaris africana, their favorite fruit in the wild. And anytime you may leave. Then the next chimpanzee come to the booth. So based on their free will, they come to participate the booth test. And to recognize who's there, we use a video camcorder to do the fully automated face recognition system. So we know which chimpanzee is doing this task. As you can see, every chimpanzee has a different stage of learning and different test. So we do the particular test for a particular chimpanzee. So that is very traditional and advanced stage of laboratory testing with computer system. What I'd say participant observation in the laboratory is very careful observation of their life. It's not me, Matsuzawa, who started the comparison of humans and chimpanzees. Almost 100 years, the psychologists in the West, they did compare the chimpanzees and humans. And their way is just like this. Put a baby chimpanzee at home. You keep the two species is exactly the same condition. You talk to the babies. Suppose that only human baby starts speaking, but not chimpanzee. And the conclusion says, language is uniquely human. I was forced to adopt the abandoned baby chimpanzee at home 30 years ago. And I immediately recognized it's not fair to compare the two species like this, because my daughter has a parents, but the chimpanzee baby has no parents at all. You take the baby out from the biological mother and put into human environment. Is it fair? It's not fair, not scientific, not ethical anymore. They are hominid. If you take a baby out from the mother, the baby look like depressing. It's not good. So, in 2000, my research partner Ai, female chimpanzee, gave the birth to her son named Ayumu. I strongly determined only one thing, only one change, different from the Western world. Don't take the baby out from the mother. So putting the baby with the mother, and I join their daily life to carefully observe their cognitive development. So that is called participant observation, started in 2000. 2005, Ayumu 5 years old. 2009, the son 9 years old. 2012, 2015. By the way, my hair was black. So not only me, Ayumu, but also my colleague Masaki Tomonaga and Chloe and Clio, Masayuki Tanaka and Pan and Pao. So the researcher, the mother, and the child. Triadic relationship. I can ask the mother chimpanzee to help me to test your kit. The tradition is continuing to the next generation, Misato Hayashi. So essentially, participant observation, it's a cognitive test in the assistance of the mother. You can do exactly the same thing to compare the two species in exactly the same situation. Even more, participant observation allows me to do something like injection. All chimpanzees, all humans, we don't like it. But based on the mutual trust and mutual respect, I can ask chimpanzee, behave. I will inject you. And it is accepted. No problem. No reinforcement training, no, nothing. Based on the mutual trust, you can do it. They are hominids. So you can do longitudinal development of the brain, MRI image, brain image, for the first 6 years, or even more, based on the MRI scanning, we got the blind sight missing part of the brain, but no fundamental damage on the daily life in a chimpanzee, or even more event-related evoked potentials. So EEG, electric encephalogram from awake chimpanzees. So this is Japanese chimpanzees, okay? Not American chimpanzees. They can behave. Put on electrodes. And just I want to introduce only one important finding. In the participant observation, we can ask the pregnant female lying on the back and use a Doppler sonar image of the fetus. Of course, the image is not precise as the brain image, but still you can measure the diameter of the brain. You can easily calculate how much the volume is. Okay? So here is the result, unexpected result. Let's compare human fetus and chimpanzee fetus, the brain volume. Of course, both cases, the brain volume increase along the gestation periods. That's clear. Always monotonically increase. But the y-axis is increment of increase. How much increased at a certain point? So linear in humans means exponentially increase. So gestation period, always increase, increase, increase. But it's not the case in chimpanzee. The increment of increase is at the maximum at the point of 22 weeks. Then the pace of increment is slowed down. Why? The uterus, womb, is so small. Sometimes you do not recognize the female chimpanzee is pregnant. The womb is small, so long arms and legs are folded in the small world. But in the human case, it's huge. So the fetus can push or touch the face. A lot of things they can do in the fetus area. Let me proceed to another example, very interesting example of 1-year-old human infant looking at the touch screen, looking at the monitor. Exactly the same situation, chimpanzee looking at the monitor. And on the monitor, there is a very simple scene of young lady orange juice, pouring orange juice bottle into the cup. Very simple video clip. The same video clip is shown to human, 1-year-old, or and chimpanzee. And yellow and red dots is a fixation point. It's gazing. Where do they look at? Look at the right side, chimpanzee case. Chimpanzee paying attention to orange juice. Only orange juice. But human baby, look at orange juice and look up the face of the lady and look down, and look up and look down. So human see this world in triadic relationship of me, you, and this object. Chimpanzee lives in dyadic relationship of me and orange juice. So it was desktop eye tracker, but now we are using wearable eye tracker. So we published papers and then assembled into the books, published from Springer and Springer Nature. Field observation in Guinea, Bosu. First of all, I want to introduce Africa because it's not so familiar to you. Africa is a huge continent that includes India, United States, China, Europe, and more. And my research site is Bosu. The country is Guinea-Conakry. There is a field station there. And since 1986, so this trip, after this conference, I go to Africa. This is the 30th anniversary, so 30th annual field trip to Africa. The chimpanzee there is known to use a pair of stones to crack open nuts, oil palm nuts. In the field experiments, in the field it looks natural, but it's an experiment. As you see, the number is attached to the stone. Female chimpanzee pick up a nut, place it on the anvil stone to crack it open. By the way, she is left-hander. So we found perfect laterality of handedness in chimpanzees. And published a book from Springer. So 4 topics: imitation, language, social bond, and imagination. Imitation. Conclusion: apes do not ape. It's difficult. Possible, but difficult. As I have shown you, it takes 4 or 5 years to acquire this stone to use skill. So this means 0, 1, 2, 3 years old. They cannot do it. So annual field trip. I wanted to know the developmental change, how they acquire the skill. Traditional, unique culture of the chimpanzee there. Oops. Cannot do it. 3 years and a half, so she cannot do it. In such a case, she goes to the mother or the other chimpanzee and look carefully in such a short distance, close distance. I don't know why, but in a close distance, they want to see what's going on. And the important point, no teaching, no active teaching from the mother and adults. And the child tried to do it by herself. So I named education by master apprenticeship. 3 important points. No active teaching, no teaching. But infants has a very strong intrinsic motivation of making the copy. And the third point, as far as the child comes, mother and adults show high tolerance. Do not say, do not chase out. So education by master apprenticeship, no active teaching, intrinsic motivation to make a copy, high tolerance towards the children. In the laboratory too, just looking. So that is the outgroup. So human, what is uniquely human? That is teaching, of course. But not also teaching, but also molding, scaffolding, helping, social praise, all is uniquely human. To conclude this section, I want to show imitation that is possible in chimpanzee. So this is in captive situation. This is the first time I show the model of using phone. It's a toy phone. It's fake. This is the first time. And the mother chimpanzee looked at my behavior, then had the opportunity and put it on the ear. So it's possible, but not as general like humans. So the second question, what is uniquely human? The second answer is language. Of course, language is uniquely human. I.e. chimpanzee is a sort of ape language study, the tail end, still going on. So she learned to use Arabic numerals, letters of the alphabet, Chinese, Japanese letters, and so forth. Today, let me focus on the number. A chimpanzee learned to use Arabic numerals and double quote, count the number of white dots on the screen. 1, 7, 5, 1, 6, 7, 3, 2, 4, 5, okay? And that is so-called cardinal aspect of number, to count the number of items. Now, ordinal aspect of number is first, second, third, fourth, the sequence. Oops. Chimpanzee can touch 1, 2, 3, 4, 5, 6, 7, 8, 9. At the age of 4, we started to teach. And 4 years and a half, only 6 months is good enough for the chimpanzee to learn 1 through 9. No problem. One of the easiest tasks. After touch white circle, 9 numerals appeared in the random position, but he can touch from 1 through 9. Clear? So this is clearly shows as chimpanzee know the ordinal aspect of the integer. So based on this knowledge of the number sequence, I tested the memory. Exactly the same apparatus and test. After touch white circle, 9 numerals appear, you have to touch 1, but in this masking task, after touch 1, the other numerals gone, turn to white rectangles. What you have to do is to touch where 2 was, where 3 was, where 4 was. I gave you the detailed explanation, so please try, challenge to the chimpanzee. Oops. Oops. Oops, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah? Touch 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? You try. 1, 2, 3, 4, 5. Don't worry, no one can do it. I know. The latency is only 0.5 seconds. No one can do it. And when the paper was coming out in 2007, not all people are happy to see chimpanzee can be better than us. Especially the person in the world, in the West, Christian people. Very clear dichotomy of humans and animals, and lots of questions, how about the training effect or experience and so forth. But the claim is wrong. Look at this one. Now 2 numerals missing, 7 numerals. But no problem. 1, 2, 3, 5, 6, 7, 8, 4 and 9 are missing. 1, 3, 4, 5, 7, 8, 9, 2 and 6 are missing. It doesn't matter, because this chimpanzee knows the sequence, the order of the numerals. Then let's go to the memory task. In this case, the 7 numerals flashed very briefly, 0.2 second. You cannot see the whole, but you can recognize the numerals are there. Two, three, something, right? You can do it. One, two, 3, 4, 5. I tested my graduate students of Kyoto University, the most prestigious university, and their performance is 0. So no one can do it. So it's not a matter of training. Chimps can do it, we cannot do it. But 10 seconds later, he can do it. So not only the instantaneous, extraordinary memory, but that memory continues for at least 10 seconds. So at the moment, we continue to know how much items they can remember, how short duration is good enough, and how long intervals they can remember. So at the moment, people are surprised about the performance of chimpanzees. But once you accept that chimpanzee can be better than us, what Matsuzawa did is I invented a new method to assess the memory. How many items, how short duration, how long interval you can remember using Arabic numerals. So in the parallel effort, I have been teaching the symbol of color. It's actually letter, Japanese-Chinese letter to the chimpanzee. White goes to the corresponding letter. Green goes to the corresponding letter. Brown, purple, orange goes to this letter. And the reverse, pink. This letter means brown. Red. Green. Gray. Through this test, I recognize chimpanzee can do it, can label the color by the symbols, vice versa. But it was very difficult. It takes a long time for us to teach this kind of things. Because the letter red, it's not red. It does not remind us any color at all. We have to imagine what this letter means. Color red, it does not remind us of any particular shape. We have to imagine what is the letter corresponding to this color. Yeah? It needs a training. So I postulated the trade-off hypothesis. The common ancestor of humans and chimpanzees may have this kind of extraordinary memory. We had such a memory, but in the course of human evolution, we lost it. In return, we got the capability of language, representing the world by symbols. So the third topic is social bond, that is focusing on stable spine posture. That makes us human. So Japanese monkeys walking on the beach. When they stop, their body trunk is upright because climb up to the trees. And their hand and feet. Look, this one. The feet looks like hands. Why? Again, climbing up trees. You have to grasp the branches. So actually, chimpanzees, monkeys, non-human primates are four hands animals, not four legs animals, four hands animals living in the tree. And in the course of human evolution, we invented foot to walk. So if you put a baby chimpanzee on the back, they raise right hand and left leg. 5-6 seconds later, left hand and right leg. Alternate. In orangutan, same. Chimpanzee, orangutan, they cannot be stable on the back. Why? They are trying to cling the mother. They are always cling the mother 24 hours a day, and the first 3 months, never away from the mother. So, evolutionary basis of mother-infant relationship, humans are unique because of stable supine posture. Why the posture is important? Face-to-face communication, vocal exchange, manual gesture. So hands are free from the beginning. It's not bipedal upright posture and walking makes hands free. No, right from the beginning, hands are free because of the supine posture. Body is supported by the back. So let me conclude my talk, imagination. Chimpanzees love to draw. This is the drawing by chimpanzee. If you show the chimpanzee photo, love to draw the face. If you show the face, love to draw eyes and mouth. So what they see is what we see. So the perceptual world is not different. The perceptual world is not different, but there is a test of showing the sketch of the face of chimpanzee, but one eye missing, both eyes missing, facial parts are missing, and it's free for the chimpanzee, and they love to draw the facial contour. No chimpanzee put eyes, nose, mouth into the face. Blank space is blank space for chimpanzees. But humans, 3 years old, verbal comments, oh, no eyes, eye is missing, and draw eye in the blank space. They can imagine what there should be. So 7 chimpanzees, always facial contour. No chimpanzee draw anything at all in the blank space. But human can put the facial parts into the blank space based on the imagination. So my interpretation, chimpanzee is looking at what is present. We are thinking about what is absent. So, yes, it's amazing, extraordinary capability. But there are numerals. So chimps are so good at looking at what is present. We cannot do it, but we can think about something missing. So, conclusion. What is uniquely human? One word, imagination. Mental time travel and mental space travel, the range is different. I don't say chimpanzee cannot imagine, but the range is different. Chimpanzee mainly live in the world of here and now. They seem not to be anxious about their future. Chimpanzees live in the world here and now, so they do not become desperate. They are not anxious about their future. They are not anxious about tomorrow. But humans sometimes become desperate, easily become desperate. However, because of the power of their imagination to think about the future, we can have a hope. Humans, we can have a hope. That's a conclusion from my research of chimpanzees. Thank you very much. Namaste.
Professor Matsuzawa, we will have questions, as Professor Menon mentioned, at the end of the session. I'm standing in for Professor Jim Bauer, who unfortunately could not make it at the last minute, and I will take my little time to go back to the field from the laboratory that Professor Matsuzawa spoke about, and from the hominids or apes that he talked about to the monkeys, which therefore represent an earlier stage of human evolution. Let me just begin with a very favorite quote of mine from Malcolm de Chazal, a very under-recognized French humorist who was born and died on the island of Mauritius. Malcolm Chazal said, "Monkeys are superior to men in this. When a monkey looks into the mirror, he sees a monkey." And that, I think, is a good starting point from where Professor Matsuzawa left off about imagination. I think monkeys and apes are perhaps much more grounded in reality than the other species present here today seem to be. And what I will do is speak very briefly about one aspect of our work in the wild on the bonnet macaques. And I've called the talk Scio, ergo sum, to know is to be. Right. Now, just for the students amongst the audience, why do we study primate cognition? And I think there are 4 important aspects to this. The first is, what is it like to be a monkey? Ever since Thomas Nagel asked this question of bats, I think we've all been intrigued by what it is to be another species, and the question is, will we ever know? Secondly, going back to evolution, how did we come to be what we are today? Clearly, the answer lies in understanding the other species as well. Third, given our current interest in neurobiology, could we understand more fully how the primate brain works? And finally, perhaps important to all of us, should not our knowledge of non-human primate cognitive abilities influence our perceptions of ourselves and our attitudes towards them? And I think this is an extremely important question that each of us has to grapple with, not only with regard to non-human primates, but perhaps other species as well. Now, the root, I think, of cognitive abilities, at least in the primate lineage, and I am particularly biased towards this view, really lies, again, as Professor Matsuzawa pointed out, in our social relationships. And the complexities of the lives that we lead, as both human as well as non-human primates, comes from 2 levels. At one level is the complexity that comes from each individual being infinitely capable of expressing ourselves in different ways, and which allows us to develop complex social relationships. But there is also a level of complexity which comes from the society, in which we have individuals of different age, sex, genetic relatedness, dominance ranks living together, and where each of us can form subgroups, alliances, and long-term relationships that cut across these categories. It is a very complex life. And if you look at it evolutionarily, that these 2 levels of complexity, when they interact, it leaves first, across space, individuals have complex networks of associations and interactions where there are many alternative strategies for survival and reproduction. But even over time, you find each individual primate, human or non-human, finds itself in long-lived social groups where they can pursue different strategies during their lifetimes. So coming back to this hypothesis of why did the primate mind evolve, I think the answer lies again in social complexity. And the good thing about this hypothesis is that we can perhaps test across species, across a range of social systems, to try and understand how social complexity evolved, and social complexity, of course, can be defined in different ways. And with this progressive evolution of social complexity, were there enhanced cognitive abilities that individuals have in these societies? Third, can certain higher cognitive attributes be defined functionally in non-verbalizing primates? I can assure you that if I spend the whole day with all of you and we don't say a single word to each other over the entire day, at the end of the day, each of us will wonder whether the other individual can think. The reason why this comes about is because we tell each other about our thoughts and emotions. Animals cannot. And therefore, it remains a challenge for us to understand what are the higher cognitive attributes that these species are capable of. What could then be the behavioral correlates of specific higher cognitive processes in wild primates or in other non-human species? Are primates capable of reasoning and abstract thought in the absence of a complex language? An issue that Professor Matsuzawa touched upon in his talk. And finally, of course, are primates perceptually and reflectively conscious? Now, the world is enormous. There are a tremendous number of questions that one can ask, and we've tried in our limited way, through observational work, to understand the mind of the monkey. But in today's talk, I will only really talk a bit about certain higher cognitive attributes and how those can be defined functionally in a non-verbalizing species. Now, I won't spend too much time on this. I'm sure all of you are aware of it. But there are certain theoretical constructs that we use when we want to understand mentalism, particularly in non-human species. Now, primates know and predict each other's behavior. I think this is very obvious. But are they as knowledgeable about another's beliefs, emotions, and intentions? And Primate and Woodruff, in a very classic paper in 1978, asked whether chimpanzees have a theory of mind. In other words, can a chimpanzee attribute beliefs, knowledge, emotions to itself and to others? Can it recognize specific mental states in itself and in others? And the hard problem, really, when you deal with a non-human species is really this. When you see an animal predicting another animal's behavior and reacting appropriately to it, sometimes even before the other animal has expressed the behavior, the question is, are they reading behaviors or are they reading minds? Have they learned associations between behaviors just as we do? Why do we look left and right when we cross a road? Because we've learned that if we don't do it, we will get hit by a car. A child will not do it till he or she learns. So a lot of our behavioral predictions are based on learning associations of behavioral paradigms. They are not necessarily reading minds. But the moment on a Sunday when I cross a road, I tell myself, today I don't have to look left and right because there are no cars today because it's a Sunday. It goes beyond reading behavior. We've started perhaps reading minds as well. And the important question then is that if an animal is reading behavior, then it can predict behavior. But if it can read a mind, it's predicting motives or beliefs. In other words, reading of behavior comes from trial and error mechanisms. But once you start predicting motives or beliefs, you replace trial and error mechanisms with knowledge-based systems. And the question I wanted to ask in this talk is, are there knowledge-based systems that monkeys have of themselves and of their social companions? Now, continuing on this line, I just wanted to raise a few important issues, perhaps for later discussion. First is, if you look at implicit mentalism, which is what I was talking about, please remember that that is also explicit behavioral experience. Reading behaviors and reading minds are two ends of a continuum. If I want to look at one of you and I get the feeling that you're bored with this talk, how do I know it? How do I read your mind? Perhaps because you're fidgeting, perhaps because you're yawning. So I do learn to recognize certain behaviors, however subtle they are, and attribute it to a particular mental state. So in other words, mentalism is also very, very explicit behavioral experience, though extremely subtle. Second, the advantage of invoking a mental state, and I will make this clear in a figure in the next slide, is that a mental state can act as an intervening variable where there can be behavioral inputs and a number of behavioral outputs, and all of this can be mediated through one mental state without necessarily learning individual behavioral connections. Let me just, the third issue I wanted to talk about is projection of experience. Today, I know what it is like to stand here, and I get an idea of what it is like to be in the seat out there. When somebody else speaks and I'm there, do I understand the experience of this other individual because I have gone through that experience myself? Can I project my experience onto others? But let me just quickly come back to mental state as intervening variable. So imagine a series of behaviors in the top figure. I have a banana, C has a banana, bananas in tree, and there are particular responses. When I have a banana, B grabs it. When C has a banana, B follows C. Bananas in the tree, B climbs the tree. D has a banana, B grooms D. E grabs B's banana, B threatens E. These are individual behavioral associations which we can learn. But if we have a mental state, which we learn from all these behaviors, that is, B wants bananas, then whether I see B grabbing my bananas or B climbing tall trees to get bananas, B following others who have bananas, B grooming those who have bananas, when I see any of these behaviors, I know immediately that I have to guard bananas from B. I will try not to take B's bananas. I will give bananas to B when he needs an ally. All of these behavioral outputs are possible simply because I have a mental state where I recognize the desire of B to have bananas. That's what I meant. So by having a particular mental state, you're capable of much more flexible behavioral demonstrations as well as behavioral predictions in others. Right. Now, we've been studying a number of very complex behavioral processes in our primates, in our bonnet macaques, and the importance of experience, of going through these behaviors to see what they are able to learn and how they are able to execute many of their complex behavioral responses. And in today's talk, because of a lack of time, I will only speak about social knowledge, one particular aspect of bonnet macaques' cognitive behaviors. Now, just to quickly introduce the species, this is a primate that usually lives in multi-male, multi-female groups, which can vary in size. Females generally tend to live in the same group, form strong linear dominance hierarchies once they reach sexual maturity. Males tend to move from one group to another, but that's not always invariable. Sometimes immigration may not happen. Sometimes it does happen, but it may be permanent or it may be transient. Males usually form very unstable dominance hierarchies through aggression and coalitions, but the bonnet macaque is also unique because males have very strong social bonds with each other, and the society is typically promiscuous with periodic consortships, ample mating opportunities, mutual tolerance amongst individuals, and very, very subtle female mate choice. Now, what I wanted to therefore tell you is that the species is extremely leads very complex social lives. And in all the points that I made, I always talked about usually, sometimes, not invariable, which means basically there's a tremendous amount of variation that we are now documenting. And it's extremely important to understand this variation because non-human species are not simply rule-bound organisms. They do have fairly sophisticated decision-making abilities, and that's the point. On the right, you see 5 males from 5 of our groups in Bandipur National Park, where we've been studying the species now for more than 15 years. We now know more than 1,500 individuals by face. They all look very different from each other, and we are able to understand the kind of decisions that each of these individuals are making. Right. Now, I will not go into the methodology, but I can discuss it later. It's primarily observational, where we try and look at certain behavioral decisions that animals make, and then try and see what are the factors that influence this decision. And the important point that I want to make here is that if you want to understand what are the rules, whether mentalistic or simply behavioral, that individuals follow when they take a decision, you have to look at behavioral choices, where an individual can do A or it can do B, and then you try and understand why it does A and not B, or the other way around, as the case may be. So today, in today's talk, I will very briefly describe one particular kind of behavioral interaction and try and understand how individuals take this decision during these interactions and what is the knowledge base on the basis of which these individuals decide. Now, you will often find 2 females who are grooming each other, and a third female who is dominant to both of them approach them. Now, several things can happen. Either one of the 2 individuals can leave, right? On seeing the third individual, dominant to both of them, appear. The second possibility is that the individual may reach these 2 individuals, females, and may proceed to groom or show affiliation towards one of them. She could also show aggression towards one of them. And we analyze these decisions to try and understand what are the rules that individuals seem to follow. So here is female A, who is dominant to B and C, approaching these two females, both subordinate to her, and either B or C retreats even before A can reach them. That's the first situation. And what you find is that in 85% of the cases, it is C, the most subordinate of the three females, which retreats, and B retreats only in 15% of the cases. And so a very simple rule for which you don't need a mind, you don't need any sophisticated cognitive processes, is to say that if I'm very subordinate, I'm sitting with a female dominant to me, and I know that because she beats me up all the time, and there's a third female who's approaching me who's also dominant to me, I decide to go. Simple rule. However, the important question is why then did B retreat in 15% of the cases? She is dominant to C, and yet she went. And to cut a very long story short, what we found, and if you look at the graph, on the x-axis, and just take my word for it, we found an index of what is called social attractiveness. Social attractiveness is when a female is groomed by all the other females of the group at very high, consistently high levels. All the females groom her. So this is a socially attractive individual. And what we found on the y-axis is the proportion of approaches that B, those exceptional cases where B leaves, we found a correlation between the social attractiveness of C, the most subordinate female, and B's leaving. In other words, it appeared from this analysis that when C was a very socially attractive animal, she's usually, over the entire period of 3 years that we studied the troop, when C was groomed a lot by other females in the group, B, even though she's dominant to C, decided to leave. We then asked, well, who does A approach? There is B and there is C sitting together, and A is approaching them. What we found was that the proportion of approaches received by A increased with the social attractiveness of B, not of C. In other words, when B became a very socially attractive animal, A was very likely to approach this pair, right? So clearly, A was also taking a decision of approaching and trying to join a female who was socially attractive, but mind you, it wasn't C's social attractiveness that she was paying attention to. She was paying attention to the social attractiveness of B, but B would leave when C's social attractiveness was high. Right? So that is what we found. So we actually, another set of data, whenever the female A approached them and groomed one of them, she always groomed B. But when she showed aggression, she always showed aggression towards C. In other words, A could clearly distinguish between who was dominant and who was subordinate amongst B and C. So if she had to show aggression, she showed it towards C. If she had to show affiliation, she showed it always towards B. And mind you, A, B, C can be any three pair of individuals in, any three individuals, a triad of individuals in this social group. So we then tried to formalize this, trying to understand the knowledge dimensions of the monkeys by doing logistic regression analysis, in which we asked a simple question: what determines the probability of retreat by any particular female from this interaction, whether you're B, whether you're C, or whether you're either of them? And we looked at a large number of independent variables. The individual who's retreating, that is B or C, her own dominance rank, the rank of the approaching dominant female, the rank of the allogrooming companion, the social attractiveness of herself, the social attractiveness of her companion, and the difference in attraction, social attractiveness with the companion. In other words, we looked at different elements of knowledge that an individual could potentially be using to model this process of trying to understand what leads to an individual leaving. And again, to cut a very long story short, what we found was this: the probability that B would retreat, remember these are the 15% of the cases, the probability that B would retreat increased simultaneously with three factors. One, her own decreasing dominance rank, decreasing rank difference with A, and increasing rank difference with C. In other words, we needed all these three parameters to actually correctly predict when B would leave. And remember that this is a very, very complex decision, right? What we also found is that the model did not work, and we could not predict the probability of B or C's retreat on the absolute dominance ranks of the other two individuals or the social attractiveness of B or C, right? So I will just come to what we concluded from this, but this model was able to tell us, therefore, what are the elements that an individual seems to be using about the dominance ranks and social attractiveness of other individuals when taking her own decision, right? And to conclude, what we found was that bonnet macaque females appear to know their own dominance ranks and those of other females relative to their own positions in the hierarchy. In other words, knowledge is egotistical. So individuals are evaluating ranks of other individuals relative to their own. And when they're evaluating it of other individuals, they're doing it relatively, not in absolute terms, but relative to each other for the other individuals. Second, during interactions with multiple individuals, social decisions are made on the basis of integrated information. How subordinate am I? What is the rank difference with the approaching female? What is my rank difference with the female sitting close to me? All these components come in when I take a decision to leave. So knowledge is being integrated. It's not a simple stimulus-response reaction. And third, individuals seem to know the social attractiveness of other females, but this knowledge seems to be utilized in terms of its correlation with that of dominance ranks. The reason why I say this is because although social attractiveness clearly played a very important role in an individual's decision, our models fail to show the importance of social attractiveness. And the way we've tried to understand this is we are arguing that perhaps knowledge is hierarchical. If now Professor Matsuzawa walks towards me saying you're taking too much time in this talk and rolls up his sleeves and shows me his biceps, or worse still, he takes out a little dagger from his pocket, I will not argue with him. I do not know him, but I do know that he has strong biceps and he has a dagger. So is it that I judge his fighting ability or his motivation to fight by certain other behavioral correlates, his bicep size or the dagger in his pocket? In other words, when individual monkeys seem to take a decision, perhaps the dominance hierarchy, the dominance ranks is what is most important, and they understand correlations of these dominance ranks with perhaps social attractiveness. When an individual is much more subordinate to me, she's likely to be more socially attractive, so I better go. So but what is very important is that individual macaques therefore appear to have experiential knowledge of the social attractiveness of other individuals. They don't seem to remember specific pairwise affiliative relationships. In other words, whenever I look at Professor Matsuzawa, I see a crowd of people around him. I know he's a socially attractive individual. I don't have to remember specific interactions that he's had with each member of the audience. Second, individuals are knowledgeable about their own positions in the dominance hierarchy and the relative dominance ranks of the other troop members. In other words, there is a certain degree of abstraction and mental representation of an individual's personal attributes in terms of the hierarchical positions and those of other individuals. I have not been able to go into the details, but during triadic interactions, dominant individuals behave as if they believe that an approaching individual is targeting their socially attractive companions. In other words, they seem to be able to attribute motives to other individuals. They seem to develop a valid belief system. However, and I can discuss this later, we do not find any evidence of individuals being able to project their own experience onto others. And this has also been seen in laboratory studies with rhesus macaques, another monkey species, where individuals, when they take on a different role in a cooperative task, they have to relearn the role. Although they may have been in the other position earlier, they do not seem to be able to transfer that information to their new positions. They have to relearn. However, a very important idea here, I think, is that while the hominids, chimpanzees, bonobos, perhaps use abstraction, they are therefore capable of a much more flexible decisions. Monkeys are learners. They are extremely quick learners, but this brute force method of learning seems sometimes to be more efficient than your ability to abstract and transfer knowledge across domains, because the price that you pay for that flexibility of abstraction and transfer of knowledge is speed. You perhaps do it much more slowly, whereas in the case of the monkeys, they may not do a sophisticated cognitive process at all. They may just be simply relearning other roles, but they do it extremely fast. So I guess, again, in evolution, there have been different lines of selections which have led to individuals of different species solving the same problem, but using very, very different cognitive mechanisms. So what are the important problems that these studies raise? First, how is knowledge acquired through experience? And what we found was that when we looked at allogrooming, the behavior that we were studying, the duration of allogrooming seemed to be a much better predictor of decisions than the frequency. Frequency, to remember frequency, you have to know how many times per unit time, which requires much more cognitive sophistication than just to look at duration and to say, overall, 50% of the time this happens. I don't need to know detailed frequency. Second, what are the mechanisms underlying the assessment of individual ranks? So, we think that there may be an inference of linear orders by memorization of all dyadic interactions, or is there associative transitivity? In other words, a sequential orderings of pairs of individuals. We don't have evidence of this from the field in the case of monkeys, though there have been some limited studies in the laboratory which have tried to look, but with food containers. The important aspect of this is that when we need to understand how individuals order other individuals, we perhaps have to look at social companions with which they interact all the time, because that's a more important decision for them. Very rarely would they have to evaluate food containers and how much food they contain in the wild. Third, there is actually no evidence yet from the wild for a truly deductive inference of social transitivity, right? Second, what is the nature of mental representation? There is no evidence yet for the formation of abstract categories of dominance or subordination in monkeys, but clearly each individual does have a conception of who is dominant, who is subordinate. How that works, what is the nature of the mental representation, remains an open question. Is there a mechanism of visual behavior matching? If I now asked you, do you know the relationship between two people on the stage? You might be able to read their body language and surmise that they are friends or they are not friends. So clearly, there is a visual behavioral code in your mind against a template against which you can match the behaviors that you observe and classify people or relationships. And perhaps monkeys are doing the same. What is also important is how is this categorization and coding of information possible in the cognitive architecture of a nonverbal species? I say dominance, I say subordination, you know exactly what I mean. How does a monkey know this? How does it categorize the information? Is it only through visual categories, is the question. And so finally, I think bonnet macaques may be inherently capable of making complex social decisions on the basis of their experiential knowledge, as for example, during competitive triadic interactions. Individual macaques may be able to form rudimentary mental representations generated by direct personal experience of themselves, of their social companions. When individual macaques may have comprehensive knowledge, while individual macaques may have comprehensive knowledge of the positions of other individuals in the dominance hierarchy relative to themselves, they may not be able to rank them in a linear transitive order or form abstractions of such a hierarchy. Finally, one must raise the question for an early evolutionary origin in monkeys going even beyond or earlier than the apes, where there is some evidence for limited cognitive capabilities characterized by an objectified self. So there is clearly some conception of yourself in that dominance hierarchy, for example, and there is a limited regulatory control, perhaps, over more subjective levels of self-awareness, where you are able to take decisions with regard to how you should behave towards individuals, evaluating them on the basis of their rank differences with yourself. And this kind of decision, if it exists in monkeys, predates those of the great apes. However, there's a question mark, because unless we do laboratory experiments, we can perhaps never confirm these conclusions. And the nature of the objective self-awareness possibly allows for a very primitive cognitive representation of yourself, allowing for self-referential behavior, enabling individuals to use their own knowledge to model the behavior of other individuals, attribute motives or intentions to them, and influence other individuals by intervening in their behavior. Such individuals may, however, occasionally hold erroneous beliefs and fail to project their experiences while predicting the behavioral motivations of other individuals. Finally, therefore, leave aside the theory of mind. Even if bonnet monkeys have a rudimentary hypothesis of mind, it is perhaps a very incomplete construct. And so this is work in progress. We are still trying to understand how, from the wild, social decisions can inform us about the conception of themselves as individuals that monkeys may have. Wanted to thank a few people without whom none of this would have been possible, various institutions. I want to end by reminding you again about Malcolm de Chazal and what he said about monkeys being superior to men, that when a monkey looks into the mirror, he sees a monkey. But let me assure you, when I look into a mirror, I see a monkey as well. Thank you. So, thank you very much for your attention. We will now break for tea. We are running about 4 minutes behind schedule. May I request you to please be back in the auditorium in another 30 minutes.